Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning. Okay, so today our group are going to present about volumetric analysis, which is titration for orange and lemonade juice. So my name is Aizat Shamim bin Ahmad Shamim. I'm from group 8. Okay, so next in the first slide we have our team members. Okay, so this is the table of content of our presentation. So first one we will cover what is introduction for the titration. So we are going to cover about titration, so the definition of titration, and then next is the theory about titration, and then methodology or the procedure to titrate orange juice and lemonade, and then we have example of results, and then about the discussion, and lastly about the conclusion. Okay, so here is our presentation goals. So the first one is we need to understand what is titration, and then we need to understand what is a volumetric analysis and common titration use. And next is how to calculate the titrations for orange juice and lemonade. And lastly, the conclusion obtained from this titration. Okay, so for the introduction, so titration is a process where a solution of known concentration is used to determine the concentration of an unknown solution. So this technique is invented back in the 1795 by a French scientist named Francois Antoine Henri Descroiselles. He was born on 11 June 1751 in France and died on 15 April 1825. So Francois Antoine Henri Descroiselles is credited with the invention of volumetric analysis or titration. So he was the first known scientist who assembled a titration apparatus, not in its current form. So as I mentioned earlier, titration is an analytical method for determining the concentration of an unknown substance in a sample. Okay, so one of the example of Francois Antoine Henri Descroiselles titration is HCl, which is hydrochloric acid, with NaO solution, which is sodium hydroxide solution.
Okay, so we move to the theory. What is volumetric analysis? A chemical analytical procedure based on measurement of volume of reaction in solutions. It uses titration to determine the concentration of a solution by carefully measuring the volume of one solution needed to react with another. So commonly titration we use is redox titration, complexometric titration, and acid-base titration. Okay, so next we talk about titration of fruit juice. Fruit juice contains both citric and ascorbic acid. Citric acid is used as a natural preservative and provides a sour taste. Fruit juice are often used as example of weak acids. The citric acid content of a lemon and orange juice can be determined through a titration of the juice. The experiment will be conducted to determine the amount of citric acid present in fruit juice. This process involves a certain volume of juice having a base of a known concentration added to it until a point is reached where all the acid in the juice is neutralized. Juice made from lemon is the most acidic. It rates between 2.0 and 2.8 on the pH scale, while the pH scale for orange juice is between 3.3 and 4.1 depending on the variety of the fruit. Okay, then methodology, apparatus and chemicals. So we have beaker, conical flask, fruit juice, orange and lemonade, NaOH 0.1 m solution, retort stand, burette, dropper, 20 ml pipette, distilled water, and phenolphthalein for indicator. Okay, so we go to the procedure. So first step is 10 ml of the orange juice was pipetted into a conical flask. Second, 10 ml of distilled water was added in the conical flask. Third, 2 or 3 drops of phenolphthalein were added as an indicator. Fourth, the orange juice in the conical flask was titrated with the NaOH from the burette slowly while shaking the flask until the indicator changed color. Fifth, step 2 and 3 was repeated 3 more times. 6, the end of point of the titration was recorded. 7, step 1 until 5 was repeated using lemonade juice. And lastly, the concentration of citric acid and acid in the fruit juice was calculated.
Next, we move to the titration of orange juice. The objective of this experiment is to determine the concentration of citric acid in the juice using a standard acid-base titration. We use 10 milliliters orange juice as our sample, 1.0 molar sodium hydroxide as the base, and phenolphthalein as the indicator. The steps are straightforward. First, we added phenolphthalein to the orange juice. Then, we titrate the sample with NaO until a faint pink color remained. This indicated the endpoint. Finally, we record the volume of NaO used, which in this case was around 12.5 ml. Now, for the calculation, we calculate the mole of now using the formula molarity times volume. 0.1 molar times to 0.0125 liters give us 0.00125 mole of now. Since the reaction between citric acid and now is in 1,3 ratio, we divide the now moles by 3, giving us approximately 0.00417 mole of citric acid. To find a concentration, we divide the volume of the orange juice in liters, which is 0.10, that give us a citric acid concentration is 0.0417 molar. Next, we titrate lemonade using same method as before. We use 10 ml of lemonade and added phenolphthalein. The titration was done with now, and this time we use 15 ml of now to reach the endpoint. For the lemonade titration, the now mole are calculated as 0.1 molar times to 0.015 liters, which equal 0.0015 mole. Again, we divide by 3 to get the mole of acid, which is 0.005 mole. And we divide by 0.010 liters to get the concentration, which is 0.050 molar. This tells us that the lemonade sample has a slightly higher acid concentration than orange juice. On this slide, we are comparing the acid content between two common beverages, orange juice and lemonade, using titration of data. As shown in the table, we titrate a sample with sodium hydroxide now and recorded the volume required to neutralize the acid. For orange juice, 12.5 ml of now was used, result in 0.00047 mol of acid and acid concentration of 0.047. In comparison, lemonade required 15 ml of now, indicating 0.00005 mol of acid, with a slightly higher acid concentration of 0.0050 mol. So, what does tell us? From the data, we can conclude that lemonade has a higher acid concentration than orange juice because it needs more now to neutralize the same volume of beverage.
Okay, so we go to the discussion. First is more acidic and less acidic. By using this method, we can determine which of the solution is more acidic and less acidic. Orange juice and lemonade juice are used as sample for this experiment. Second is volume of NaOH used. We have determined the amount of NaOH that is needed to neutralize the acid. The average of NaOH used to neutralize both orange and lemonade juice are 12.5 ml and 50 ml respectively. It shows that the volume of NaOH used for lemonade titration is higher than orange juice. Okay, next, concentration of citric acid in fruit juice. We have figured out the concentration of citric acid in lemon juice and orange juice that we use in this experiment. For orange juice is 0.0417 molarity and lemon juice is 0.05 molarity. And lastly, precaution must be followed during the experiment. Firstly, this is important to place the eyes exactly at the level of meniscus when recording the burette readings. The eye level must be perpendicular to the reading when recording the data to avoid parallax error. Other than that, titrate the fruit juice in the conical flask with the NaOH from the burette slowly while shaking the flask until the indicator color change. This helps in achieving an uniform mixture of the reactants and the reaction proceeds at a faster rate.
Okay, so now we're coming to the conclusion. Okay, so in this experiment, titration was used to determine and compare the acidity of citric acid in lemonade and orange juice. Okay, so the volume of NaOH, or sodium hydroxide, required to neutralize the acids in each drink was successfully recorded. Okay, so how it becomes successful? So it becomes successful by titrating each sample with a standard sodium hydroxide NaOH solution using phenolphthalein as an indicator. On the other hand, we can conclude that lemonade and orange juice has a high concentration of nitric acid. So the results showed that lemonade and orange juice required more NaOH, sodium hydroxide, to reach the endpoint, indicating that lemonade and orange juice have a higher acid content. Okay, so this experiment successfully demonstrated how acid-base titration can be used to analyze the acidity of beverages and also highlighted differences in acid content between fruit juice. There are few of limitations or possible source of error, which is include measurement of liquids, incomplete mixing, or difficulty in detecting the exact endpoint. But despite these limitations, the titration results provide a useful comparison of the acidity levels in orange juice and lemonade. Okay, so here is our references. We use 5 different websites to make this video presentation. Okay, so we have reached the end of our video presentation. So if you guys have any question, you can leave your question in the comment section below. Okay, so thank you for watching.